Hey everybody, we're in Palo Alto right now, and we're in front of the one of the R&D centers for Rivian. As you can see in back of me, there's plenty of Rivians here to look at. So today, what we're going to do is we're going to interview a few of their scientists here, and I'm also going to get a chance to talk to RJ. Stay tuned, it's going to be a lot of fun. Okay, so now we're going to introduce Vidya, and she is going to tell us a little bit about herself.
Yep.
And then we're going to look at what we call electronic bugs. These are the kind of things that you'd see with the wires and the little boxes and whatnot, ECUs. And this is what you'd normally see inside of pretty much any OEM. And Vidya, why don't you tell us a little bit about you, and then we'll get you to tell us about this.
Great. Thanks, Sandy. My name is Vidya Rajagopalan. I lead the electrical hardware team here at Rivian. Electrical hardware is all things electrical, low voltage, high voltage, all of that. I've been here at Rivian almost 4 years now. Prior to this, I was at Tesla doing similar stuff. And then prior to that, my background was actually for a very long time in the chip industry, building microprocessors, systems and chips, and the like.
Oh, wow. Oh, that's a giant leap to go into that. Yeah.
There's so much with semiconductors going on in automotive. It was actually quite a logical transition. So.
Wow, cool. So what are we looking at here? Can you describe a little bit of, this is the Gen 1, right?
That's right. So this is a Gen 1 lab car. It shows you the guts of all the electronics and the devices that are inside the body of a vehicle, which you never get to see. And this is a Gen 1, so it has all the controllers. The big change we did from going from Gen 1 to Gen 2 is we significantly reduced the number of ECUs, or electronic control units. We went from 17 unique to 7. And what you will see is, if you go around, is we have a lot more sort of parts or ECUs around here. They're tucked away here, so not maybe as visible to the camera. But in order to make all these work, we have a lot more wiring. So when you have more boxes to connect, you naturally have a lot more wiring. And what you'll find, for example, this is a harness here called the dash harness. It doesn't even exist in the other vehicle that we'll see behind it. Or for example, right here, we have, for example, in the ECU consolidation, we'll be showing you more in detail. This is something called a door control module right here. And you'll see one on each door. There's one tucked there, there's one there, there's 4 of them. When we consolidated all the ECUs, we moved all that functionality into our zonal controllers, so we just don't have these parts anymore. So smaller, better, fewer connections, fewer wires.
Well, there's quite a bit of wire that has come out, over 1.5 miles or something like that.
1.6 miles, yep.
1.6 miles. So that's quite a bit. There's a little ball of copper that we were trying to guess how much it weighed. What is the weight of that ball of copper?
Very good question. I need to go back and check on that one.
Okay.
I used to remember the number, but yes.
Yeah, well, I would guess around 40, 50 pounds.
Yeah, yeah. We reduced 44 pounds on the vehicle by doing all of this, but just from the electronics piece. But the wire versus the controllers, because when we consolidate controllers, you actually save a lot of in the enclosure weight and in the controller itself. So.
Well, getting rid of 20 kilos is a big deal for anybody. Actually, most car companies will pay money to get rid of weight. And so that's a significant chunk of change and then a significant amount of cost reduction for the whole car. Yeah.
Cost, reliability, service, all of that. It actually helps all of that.
So what was the thing that was let's say the biggest, had the biggest impact with your redesign on on, let's say 1, 2, we're going to go over there.
I think definitely the biggest thing was the move to zonal controllers.
Yeah.
And so we had a lot of discrete controllers like the vehicle dynamics module, the body control module, the thermal management module, the different door control modules, the seat control modules, and many more, right? We took all of them and put them in 3. One called the West, East, and South. So just 3 of them. So we consolidated all that. And by doing that, obviously, we have fewer controllers, less mass, less wiring, less connections. But we also did one more thing is we went from thermal fusing to e-fusing, which again helped reduce mass, and also a lot of discrete, fuse components disappeared and they went into PCBs, right? So that all of that was probably the biggest change, but it was really enabled by the software work, because now you had the beauty of the original design, which was more domain focused, where you had one ECU that only worked in body controls and another one. It's a lot easier for the software teams because they just focus on one of them. So what we ended up when we consolidated all these, we made it harder for the software team. So Wasim can talk to you about that and on the challenges that comes from that design, but it's obviously very beneficial, right?
So when you were going through all of this stuff, so Tesla jumped into 48 volts and they have an Ethernet ring and stuff like that. Did you guys consider that, or is that?
Absolutely. We look at that all the time. So first of all, we have Ethernet. We have plenty of Ethernet. Ethernet, the reason you have Ethernet gets you bandwidth.
Exactly.
And so we have Ethernet where we need the bandwidth. But if you look at a lot of the controls in the vehicle, they don't need that kind of bandwidth or throughput because they're really very low bandwidth signaling, like a door handle or something like that.
Yeah.
So we chose not to put Ethernet everywhere. It comes at a cost.
Yeah.
Ethernet is also not a bus. It's a switching topology. So we thought about it. We looked at it. It didn't make sense for this. And same with 48 volts. What 48 volts gets you is thinner wires. And that makes a lot more sense depending on your current load. We don't necessarily in this design have that, there's a trade-off. You cannot go to all 48 volt because legacy devices are sitting on 12. So you end up having a dual architecture.
Right.
And so where you win in the copper, you lose because of the dual. And so you do the trade-off on the vehicle. And if you have very high current loads, it might make sense. So it may have made sense for Tesla. For us, it did not.
Okay, so let's go and have a look at the new generation, the Generation 2. So maybe you can point out the fact that there is no
You see, there's
harness.
no wire here. Yep.
Yeah.
That whole dash harness is gone. And we actually have it in the other room. We'll show it to you. And you can see how heavy. You can get a sense, appreciate really how heavy it is. The door control modules we showed you earlier, they're gone. If you look at the door structure here, much simpler. The box we showed you, the door control module is gone.
The thermal fuse as well is gone. The
That's
big
right.
box that was there. The harness is much simpler.
Yeah, and if you had looked, this is a much thinner bundle out here. Even though it's not gone, it's much thinner. And the zonal controllers, so this is the West. There's one on the other side called the East, and then the South is at the back here, right here. And that's it. These are 3 controllers that just control the entire vehicle. So the South controls all the I/O in the rear of the vehicle. The West controls all the I/O on the left side in the front. And then the East controls all the I/O on the right-hand side. So that way, most of the wiring that's, all the I/O in this side or that side is controlled by here. And so you keep wiring shorter too. We have a really good picture on our website somewhere that shows you the runs, the wire runs, and shows you how it's really all very controlled. It's sort of my favorite analogy is like a post office, so like you sort of have post offices that serve your vicinity. So this zonal controller serves all the I/O in this vicinity, and that way it keeps the wires tight. So whereas in the old domain-based design, if you had a body control module that controlled lighting, it would control lighting across the entire vehicle. So wires would snake over everywhere, which is very inefficient because wiring is a huge contributor to mass.
Well, it's too easy to it's too easy to nick. The operators that put the cars together hate wiring. They always give wiring to people who are new on the job because no one really wants to fool with it.
Yeah.
So on and on and on. And it's really easy to mix up connectors.
That's right.
And for me, the faster we can get rid of wiring, the better I think the vehicles will be in the future. Yeah, yeah. So I'm looking at quite a bit of stuff here that well, I'm looking at quite a bit of stuff that disappeared. What I'm trying to say, that isn't, what I'm looking at is a much cleaner, I mean, there's a lot of things that appear to be missing with the zonal controllers. And quite frankly, that just makes me happy as a clam. I'm very interested in finding out how we can get to much more efficient, especially when it comes to wiring and plumbing. I really think that it'd be a great idea if we could figure out how to move away from as much of that as possible. So which area of the vehicle you're the most, and you're probably going to go back to the doors, but which are you, apart from the doors, which area are you the most proud of?
I would say all over. We just did such a big overhaul of the architecture.
Yeah.
And I'll use the sort of a zip code analogy now. What we did is we reassigned everything, and now we have everything in the right zip code. And what we're going to do is really start working in that zip code and keep it, this is a continuum, we keep working on it, but we can start focusing on, optimizing within that zip code as opposed to rejiggering everything else. This was a massive overhaul. The zonals, I've had to pick the two biggest things. The move to zonals was obviously one, and that's not localized. It's all over the vehicle, and it had wide impact both on the controllers and the harness. But the other one is the ADAS, which we'll talk to. We totally redid that. We gave it much, much more compute power, and we gave it new cameras, which are really forward-looking.
You also gave radar, right? You increased. So some of the companies are moving away from radar, and you moved into it.
Yep.
LiDAR has never been one of my favorites, but FLIR, I work on defense stuff all the time. That's the only thing I could count on. It's the only thing that looks through fog and everything else. So what made you go to the decision? Like you've got at Tesla and just cameras, and you've got radar, and others got LiDAR. How did you come up with the decision?
With the decision, yes. So I think we're a company, we don't believe in single modality. I think, at least especially for where we are in our trajectory, we believe in multimodal sensors because they really give you some sort of robustness when one sensor is not as, you're in a situation where one sensor is not likely to perform as well because it's the weak mode for that sensor, right? So I think we have very strong belief in multimodal sensors. Hence, we have radars. We have 5 radars. We have 4 corner radars and 1 center front imaging radar. And we actually went up sort of in the type of radar we have. So we definitely do believe that you need multimodal sensors and that they compensate for each other because no sensor is perfect. Like you alluded to, it's not perfect in all scenarios. LiDAR, we consciously chose not to put now because we think, at least in the R1 Gen 2 timeframe, the cost point and the mass production is really not congruent, aligned with introducing in a mass-produced vehicle in this timeframe. But yeah, we definitely believe in dual sensors for robustness.
Yeah. Well, I've been listening to different people. I try not to make too many comments about, what is safe enough or what have you. That gets controversial in a heartbeat. So I'm interested. I was very interested when I found out that you were moving. Well, you already had radar, but moved it up a smidge.
That's right.
And I expect that as you reduce cost over here, you could afford to put more cost over there.
That's right. That's right. And we actually designed the ADAS hardware to be really forward-looking. So we, our cameras, front-facing cameras, are 8 megapixels. So we really went up in the camera resolution, and that was so that we could really build hardware that's just reliable for that's really looking forward, right? Forward-looking, and the big thing about autonomy and ADAS is really data collection and training. And so once we have this, it's really about all the miles we'll collect on the R1 Gen 2 vehicles. We'll collect them on these really much more upgraded sensors, and then we'll train on them. So there's really no need to really quickly upgrade these anymore. We have cameras that are going to be there that'll serve us well for a very long time ahead. Right?
Oh, excellent.
And then we don't have to keep retraining and retraining on new camera data. We have forward-looking cameras that are really generation ahead.
Yeah, so we were talking a bit ago about facial recognition or retina recognition. What do you see as the next generation of your particular part of the vehicle? Where do you think are...
In terms of key, replacing a key,
right.
I think that technology, is one of the different ways. We definitely don't have it in R1 Gen 2. We look at all technologies for the future. One of the things is that the phone works so well. Right now, the phone, watch, all of those. Yeah. And almost everybody has a phone. So a biometric sort of face ID detector could be useful over time. But, right now, they're not as foolproof, I would say. But we keep our eyes, open.
Well, the one good thing about phone recognition is if you forget your phone, you can't open the doors, and that reminds you, maybe you should go and get your phone and that kind of thing. But the problem with a phone is you drop it in for charging, you forget about it, and the next thing you know, anybody can walk off with your car. And I've done that way too many times already where, I just forgot to get the phone. I'm gone for 2 or 3 hours wondering where my phone went. Yikes, it's in the car, you run back over. Luckily, nobody spotted that the phone is, sitting there waiting for whomever to sit in and take off. But anyway, that's just, I forget a lot of things.
We'll have a solution for you, Sandy. We'll introduce next year the watch.
Yeah.
So the watch will remind you. Sandy, you forgot your phone.
Okay, I have a watch. Here it is right here. Okay, so this watch is the watch my mom gave my dad when they got married.
Oh, that's lovely.
So so this one's from France, and it's 19. Inside it says it's 1944, but my mother gave it to my dad just after the war when they got married in 1946. So
in France?
No, not in France. No, in Windsor, Ontario, Canada.
Okay.
Well, that's pretty special.
But this is my special watch. I only brought it because I knew I was going to be meeting the two of you. So anyway, why don't we ditch this and head to your playground? We've already been to Wasim's, so we have to go and see yours.
Come on over. We'll take you there.
Okay, good. Let's go and have a look.
Awesome.
Okay, so Vidya is going to tell us a little bit about all of the stuff that's going on here. So I just looked at some kind of cool things on the way up on the circuit boards, but we have to start here because this is really special. Vidya, before and after, it's all yours. Yeah.
So one of the things we talk a lot about is how we went from Gen 1 from our domain-based ECU architecture to our zonal architecture. And this is a great representation of that. So on the left here, we have ECUs, the main ECUs, not the small ones, the main ECUs and fuses from a Gen 1 architecture. And then on the right is the equivalent of the Gen 2. It's a very simplistic view. In what we say often is that we went from 17 unique ECUs to 7. On the right-hand side, it's easier to count. You don't see all 7. We show you 5. Because the other 2 are really small, so we haven't mounted them up on this board, but it gives you a sense of the scale of what we did, right? So these are all the sort of the zone controllers and the autonomy infotainment computer, the big controllers, and these are sort of the fuse boxes that you see, right? And I think, and you see that, and I think I showed you the door control module earlier. We have those. All of that got replaced by just these 3 things. So we have the south zone controller, the west zone controller, the east zone controller. So 3 zone controls, as we talked about. Our big, powerful autonomy infotainment computer, the BMS. And so these are 5, and we have 2 more really tiny ECUs. That's why we don't put them up, but they're really vehicle access controls. But this is really the bulk of our low voltage electronics in Gen 2. And if you look here, we have just a lot more stuff, which, as we know, means more cost, more mass, more wires, more connections.
Slower
all of
response,
that.
on and on, yeah.
And we have the same thing down here, broken out. So this section shows you the Gen 1 ECUs. And the ones that we didn't mount up there are really the vehicle. They're really tiny ones. They're for vehicle access. This is the door handle NFC. This is the vehicle access Bluetooth module. That's actually, there's 4 of them around the vehicle, so that when your phone approaches it, you can see it. And then these are actually the 3 zonal controllers exploded. This is the south zone, the west zone, the east zone, and then you can see the inner guts of it. And what's really very interesting to see is these big thermal fuses that you saw here, they are replaced by semiconductor chips here, right?
Mm-hmm. Yeah.
So the power of really semiconductor electronics shines out here. And these 3 controllers control everything in the vehicle in terms of body electronics, dynamics, thermals, all of that.
Wow. Do these also control the audio, visual, all the?
No. So that moves over to this side.
Fine.
So this is sort of the zonal control domain. This is the BMS of the battery management system. These are the same Bluetooth vehicle access modules we talked about earlier. This is the NFC door handle module, and that's just the inside of that. And then this is sort of the big computer, which does, this side here is the autonomy side of it, and this side is the infotainment. So the infotainment piece here controls the display, the audio, all of that. It's a Qualcomm processor, very similar to Gen 1. Over here, we didn't necessarily go for big change, because the upgrade here comes from features and feature improvements in software. But this on the left-hand side, my left, your right, is the autonomy computer, where we went for a massive change. You see 2 dual NVIDIA Orin processors here. There's 2 of them. This board is almost symmetric, as you can see. This is mirrored. So we have 2 processors computing concurrently. And this is the enclosure it all sits in. As you can see, it's a liquid controlled module. You have fluid going in through one of these and coming out from the other. It's a much higher power system, obviously, which is why it needs that.
So this is just flipped right over the top of that.
That's right.
And well, I'm not going to do that, but that's what the ribbon cable is for.
That's right.
For communication.
Exactly. It's a board-to-board connector. One of the philosophies we have is this computer gets access to all the cameras. And the idea is that all the sensors in the vehicle should be available to everybody. So all the high-speed data from here is actually funneled over to the side.
So you're cooling contacts to these areas here.
Exactly.
How can you show us that?
Let me see
I
if we
imagine
have.
it's going to be on the opposite side there.
Yes, if you see this, you can see the pipes.
Yeah.
The coolant flows through these pipes. These are all the pedestals that make contact with different parts. So we have, on both sides. So these are actually, so there's something called a thermal interface material that you apply here, and then that makes contact to a chip. Right?
Yeah. Basically grease.
Yes.
Yeah.
Just very conductive.
Yeah.
One of my colleagues likes to say that this is probably the most powerful computer you own at 250 tops. If you think about it, like a MacBook or something is well under 100 tops. So, he often says the most powerful computer you have is actually in your driveway.
Yeah, yeah.
When it comes to AI compute.
Yeah. It's funny, when I started out, there was no computing power in a car at all. Stumbling along, and we did any auto world, stumbling along, we're now into a situation where looking at this is the kind of stuff I expect to see in space applications, or jet fighters and things like that, where tens of thousands of decisions have to be made in basically a half a second. Yeah, so this is really, really impressive. Wowzers. How much different is this than whatever was over there?
Yeah, so the equivalent, and we haven't it opened up because this side has so many parts. This one is closed up, but this is actually an area which is, the infotainment side is not that different, but the autonomy side is sort of a night and day.
Yeah.
We significantly went up in compute, 10x, the amount of compute. And even the architecture is actually much more simplified. In Gen 1, that was also a multi-board solution. And in fact, it was actually dispersed. See how this says autonomy safety module?
Yeah.
It was actually dispersed over multiple ECUs. There was this one. There's a Mobileye camera, which is also not here, but there's the parking. This is the park assist module. So we actually had 1, 2, 3, the Mobileye camera, 4. So that compute was spread across multiple ECUs. Now, all of that is consolidated into just this one board.
Which basically is twinned, right?
That's right, it's twinned.
So
yes.
That's what gives you your double redundancy, or
That's
at
right.
least, yeah.
That's right, yeah. And so, things that were really spread across multiple computers got put in here, and we have significantly much more compute, even compared to if you added all those different modules together.
So I know that you develop your own software and whatnot. Do you actually make your own circuit boards, or are you
Yes, we make
purchasing?
our own. We
You
make our
your
own. So all of these designs you see are in-house designs. Our teams are actually spread around here and in Irvine. They do schematics. We obviously work with the chip suppliers, look at their reference designs, and use them as a basis, but all our designs are ours, uniquely ours, in-house, done from scratch.
What about the actual PCB manufacturer?
So the manufacturer itself, it's built to print. So we do the layout. We go to different suppliers. We code it to them and have them built by PCB suppliers. And then we actually have the SMT, or the actual assembly process of the components and the enclosure done at a contract manufacturer somewhere. And we bid them out to different suppliers. It changes from program to program. Yeah.
Yeah. Wow, this is all really impressive.
Yeah. And
so what's that big buy?
well, before we get there, let me show you quickly. I talked about, we designed our cameras in-house this time for Gen 2. And if you see across the board, we have resounding positive feedback on our Gen 2 cameras and the clarity. As I mentioned, we went up to 8 megapixel cameras for autonomy, but these are our cameras that feed this computer. I just thought I would show you that. But we focused a lot, not just on getting higher resolution. We, as I said, our driver-facing front-facing cameras are all 8 megapixels. We went for better resolution. We went for better low light performance, like you talked about. It's really critical with ADAS to get good low light performance. So high dynamic range. Our cameras in this generation have LED flicker mitigation, which means, LEDs flicker. And if you look at traditional cameras and you take pictures, you'll have missing dots, where the LEDs are. These cameras have newer sensor technologies that actually, because of the refresh rate and all of that, they don't suffer from LED flicker issues. So imagine having a traffic light you want to catch.
Yeah.
These will catch them correctly, as opposed to, if you take an older camera and you try and capture traffic light, you'll find missing dots.
Yeah.
These don't have that limitation.
So do you manufacture these, or have someone
We
manufacture
have them make
under
it,
license?
but we spec it fully. Yes.
Yeah.
Under license, yes. These are custom made for us. And the clarity is, orders of magnitude better from our Gen 1.
Wow,
Yeah.
that's amazing.
But
And
you were
now-
asking about this?
Yeah.
This is that same dash harness that we said is no longer there. Gives you a sense, try lifting it. You're not going to be able,
Well, you can lift it, but
Yeah,
it
not
has a
easy.
mind of its own.
Yes.
And this is why I'm trying my best to, when we do redesigns of products and whatnot, I try and get rid of as much of this as possible. Because, like you said, try lifting this. Well, try lifting it like every 60 seconds.
That's right.
To get a car out the door. Most engineers it doesn't really, it doesn't phase them or it doesn't react with them until we do something. We like to do something called Genes Days, where we take the engineers out and say, okay, you can get to put it together for a day. And usually by about lunchtime, they're saying if they had to do another harness, they'll quit. So this is a lot of weight, cost, and certainly misery associated with trying to put this together inside of a vehicle. So eliminating all this is like amazing, absolutely amazing.
And this is not the only wire, but we put it here because this is that whole missing dash harness.
Yeah, right.
As I said, all the other bundles got a lot thinner too, so this
Yeah.
is not the end of it.
No, but this
Yeah.
one here, the crosscar, or crosscar harness and the harness for the IP, those are the two that people struggle with the most.
Yeah.
So having a look at this, wowzers, this is a lot of wire. Not only that, somebody has to make that harness, and then you pull it out of the box, and then you try and unfold it so that it kind of is in the right place.
Right.
It's like station after station after station of people fiddling around with just this
Exactly.
and this alone.
And one of the, like you said, the hardest problems in the factory is connections. People make connections, they miss connections,
Yeah.
and
Well, these ones here are not bad. These ones are rotary, so you can, once you've plugged it in and you swing it shut, it'll click and it'll make a noise. Some of them, not so much, like these. These, you push them in and keep your fingers crossed. Now this got TPI. No,
Yeah.
they don't. So these ones here, you push them in and hope you did your job. And then at the end of the line, or at the first station where you do any kind of quality checks and whatnot, okay, now you get to go and chase down something that doesn't quite work.
That's right.
Every one of these wires is a failure point. Every one.
Exactly.
And so that's why you want to have high quality, get rid of a lot of this. Yeah, I'm amazed. This is really quite good. Yeah. Well, Vidya, you have given me a heck of a tour. I'm ready for a nap now. Anyways, thank you so much.
My
Thank you.
pleasure,
Really
Sandy.
appreciate it.
Really
Thank
enjoyed
you.
it.
Thank you
Yes.
so much.
It's always great to see you in person. So.
Well, thank you. Thank you. I'm glad to be seen. Yeah. So anyways, let's move on to the next phase.